about data analytics and AI, right? Why is that important? It's a bunch of things brought together. The founders of Databricks, we were at Berkeley about 10 years ago, and so we were seeing in all these industries, a lot of these players were basically driving significant disruption. You can talk about the Amazons. I'm still not used to calling them Meta. I'll probably refer to them at Facebook, Netflix, and the like. And so what they did was they said, look, we have this huge corpus of data, and typically these worlds have been separate, right? I have all of my data, I figure out how to do some analytics on it, and then I have machine learning over on the side. What happens if we bring them together? The insights that you could bring could basically transform and revolutionize businesses. And so for us, we're like, this is phenomenally interesting to see some of the use cases. Some of them, not so interesting, but some of them were like, look, this could actually revolutionize the world. But then, why should it only be isolated to this small set of organizations? So one big belief for us was that in 5 years, from now, every company will be defined by bringing these things together: data, analytics, and AI. And you're already seeing a lot of organizations there, and I think even faster than 5 years, we may be able to get there. So now let's talk about that in a little bit more detail. What does that really mean? Like, why do I care about it at a high level? Okay, we talked about disrupting organizations and industries. What are some of the things that you could do with it? And so look at the use cases. One, customer engagement. So a lot of organizations are now trying to figure out, how do you tailor what do you do? How do you bring the customers together so they're basically have more relevance and hyper-personalization? Next, you could see ones who are looking at, how do I put out new products? How do I look at things of becoming much more predictable and things that I can put out there? A third use case that you look at is from a workforce perspective. Everybody bringing people back. What are they doing? How do we make sure their experience is better? How do we help them live up to their full potential and be excited about what they're doing? And then lastly, you look at just business operations, right? How do I think about efficiency, profitability, costs in this day and age? So these are the categories of things that people are looking to do. Now, if I look at it from a spectrum perspective, we see the world in the following way, what we call almost this maturity curve, going from what we say hindsight to foresight. So on the left side is things that we've historically looked at. What did happen, right? What did my sales look like? What does my supply chain look like? What did I actually sell? We've been doing that for decades. But then people are now trying to figure out, how can I be more intelligent? That's where the disruption comes from. So how do I maybe figure out, what is going to happen? Why did it happen? How do I drive change? Can I automate that happening as well? And so what most folks want to do is that they want to be able to span this whole spectrum. And if you look at it now from a, this is what we want to do, what about from a technology aspect? You'll see it's combined of two things, right? The BI or business intelligence space, which is a little bit of like the left side that I've talked about. AI is on the right side. So it's this concept of saying, can I actually understand what happened and apply this past, all the occurrences, to figure out how do I predict the future and influence it and change it, bringing these together. And it's not about picking one or the other. The whole point is you have to be able to span that spectrum in order to be able to be successful. So we've been talking a little bit at a technological level and a little bit abstract. Let's look at some organizations that are successfully doing this. So one that most of us are familiar with, Rolls-Royce, right? Engines behind the planes. And so one interesting use case for them is that it's actually extremely expensive and difficult if you have to ground a plane, right? Because you didn't know what happened, something went wrong. You look at, oh, I have to get much more planes out there. They're flying the way that they shouldn't be. So they gather all this data from suppliers, from streaming IoT sensors, all of it. How do they actually bring that together and much more intelligently predict maintenance needs? The one thing that is clear is if you know something is going to basically have an issue or go out of service, fixing it ahead of time saves a significant amount of cost and productivity versus having it break and then trying to scramble and doing it. And so by being able to take all this data, do analytics and AI on that streaming and supply chain data, you could see that they estimate at least 22 million tons worth of carbon emissions saved because they were so much more efficient with their planes and engines. Okay? So now moving from the manufacturing space a little bit to a healthcare space. Amgen, an organization in the US, one of the things is when you are looking at understanding, finding drugs and drug targets, two things that are very difficult. One is, how do you actually go figure out what early discovery targets are? You're tending to do a bunch of genome sequencing, identifying what could work. These are hugely complex and time-consuming operations, and what ends up happening, because it's expensive and difficult, you end up taking bets. How do I only run these experiments? Here's my 10 hypotheses. Hopefully we find one. And it's why, as a result, that the yield of actually finding something successful is so low. But what Amgen was able to do is say, okay, look, I look at that, and I look at clinical trials, which is now when you move it forward, which is also difficult. So much data, how do I sort through it, human intensive? What if I could bring this all together? I could grab all of the data that we have and then run it through kind of a far more brute compute and intelligently run through everything. Can I find drug discovery targets faster? And can I be much more efficient and effective in the clinical trials that we run? And you could see that in the early days, they've already said over $100 million has been saved in clinical trial costs. And they've publicly gone out there and said, look, there's just basically drug targets that we found in drugs that we're not sure we would have gotten to, or it would have been far longer for us to get to otherwise. Okay? And then lastly, let's look a little bit more in the telco space. So AT&T, one of the challenges is, most of us don't know, is like the phones that you use in the telco companies, like the sheer amount of data that they collect. And there's so many transactions that are going out, especially in this day and age. People are worried about what about fraud, what about abuse, all those things, whether it's through streaming, whether it's through online, in-store. These are all interactions and touch points that are going through. And so they looked at it and saying, by being able to bring all of this data together and in real time understanding what was happening, basically their ability to drive down fraud and abuse across 180 plus million of their customers was immense. And it was something that they had never been able to do before. And there was a ton of other benefits around basically customizing their customer experience as well and being able to deliver new offerings to them. Okay, so these are interesting. They're clearly bringing together data analytics and AI. How and why isn't everybody doing this, right? So if we look at it, we say most organizations still struggle. It's really difficult to do this today. And whenever we talk about anything, that there's technology, there's processes and people. The latter two are clearly very important, but many people get stuck on the technology as well. So let's talk about what some of those challenges actually look like. So one, let's start with all the data sitting in the data lake. Over 90% of the world's data sits in the data lake. That's where it starts. But now, how do I get value out of it? So the first thing I've got to do is, most of the data I dropped in there is raw. I've got to change it around. I've got to transform it into something meaningful, and I have to orchestrate all of that. Now, what most organizations have done for decades is say, okay, I'm going to take that data and I'm going to copy an element of it into a data warehouse for structured formats. Now, we all know the second that you say copy, it's a bad idea. You're thinking about cost. You're thinking about challenges of keeping them consistent as well. Okay, so now I have some data in the data lake and some of it sitting in the data warehouse. And I need to use both. So the next thing is, clearly because nobody cares about security, why would I care about governance? The reality is that's the big thing now. When you put the data out there, who's using it? Why are they using it? How do I secure it down? How do I have provenance? But I have two different systems. Now I've got to figure out in my data warehouse, how do I think about tables and structuring that? And the data lake is more around files. So great. Now how do I secure that? Again, you've created two different security models. How do you think about them being consistent? How do you make sure you're truly securing what you have? And then it's, what do you do with the data, right? So data warehouses are the domains that we talked about, BI and business intelligence, being able to ask that question. But on the other side, you want to do data science and machine learning, and you want to look at real-time applications as well. And here's the problem that you have. Notice in none of the use cases that I mentioned, oh, you know what, Rolls-Royce has a BI use case, or AT&T has a streaming use case. No, we said we have a predictive maintenance use case. We have a customer 360. We have a fraud detection use case, which means you have to touch all of the data and go through all of these different systems. So what are some of so there's a bunch of downsides that come from that, but the problem's actually even worse than that. So now that you've done this, the reality is pretty much every organization today is multi-cloud. They're either aggressively going towards multi-cloud or they're multi-cloud today. So this complexity of these systems that you've built Now you've got to replicate it. So let's say you have one model on AWS. Now you've got to reason through, how do I do it, whether it's on Azure or basically on GCP as well. So you replicate. So you've kind of just compounded this complexity that you have. So what are some of the major challenges we see organizations have with this? A, it is incredibly complex as a model to do. You have all of these different workloads across all the clouds. How do you organize them? How do you think about them? How do you put it together? What works? And we all know that whenever you have many things you're stitching together, it's not the individual system. It's the glue between them that creates friction and challenge. And why do we care about complexity? Well, complexity, A, means significant cost, and B, it's a huge loss of productivity in being able to enable your organization. So the second thing is almost all of these are these proprietary walled gardens, right? And when you build these walled gardens, the challenge is it's not portable, and they almost always make it much easier to get in than it is to get out. And the reason that that's important is I'm a firm believer in the technologies we will be using 5 years from now. Many of them either don't exist or they're in research institutions or academia. And so you don't want to be sitting there thinking about re-platforming all the time. So how do you think about future-proofing and evolving? And if you've locked things into a proprietary world, by definition, it's going to make it very difficult to do. And then the last thing is that they're super cloud specific. Right? Everybody will say, build this for my cloud. But the reality is when we talk with organizations, they want to step back and say, how can I be, kind of multi-cloud, cloud native? I want to deeply integrate with the benefits of the cloud, but I don't want to be an expert in their stacks. I don't want to think about how do I optimize it. And I don't want my end users have to think about, here's how you operate when it's sitting on AWS, and here's how you operate when it's sitting on Azure. So what do people really want, right, as we're seeing the principles? So one, from a complexity, simple. Right now, what does simple mean? It means that they want to start with saying, how do I have the least number of systems in there? I don't think at the end of the day you'll ever have, one tool to rule everything. Doesn't make sense. But the example I like to give is from smartphones. The reality is most of us, when we get our smartphones, the first thing that we're going to do is say, hey, I'm going to download some other third-party app because it serves a need that I don't have. But do you really want to be carrying an iPhone, an Android, and a BlackBerry in your pocket? So how do you reduce the number of tools, both from a cost perspective and an ease of management and productivity? Second, it's this notion of open. And if we were going back 10 years ago, everybody, when they think about open, it's just like, well, are the bits open source? How do I get support and services around them? That's not exactly the model that people care about in the cloud, because most people will consume things as a managed service. But instead, from an open perspective is, as I mentioned, think about if all the innovation is new, what's important to them is if you're a small startup, take it from us, we were created, what do you want to optimize for? Some random proprietary format that you don't know if it's going to be successful, or an open format that has a large ecosystem of third-party vendors supporting it. I have high portability as well, and I feel like I'm not locked in. Right? That's the second piece. And the last one is that multi-cloud. And that means two things. One, I want a single pane of glass that I can look at and understand how do I think about all my assets. And second, I want to be able to migrate between them. And three, I want to get the benefits of the clouds, but for an end user perspective, they shouldn't have to think about that. Why do you need that cognitive overload, right? So when we take this together, that's where this concept of a lakehouse comes from, that you could say all of your data, analytics, and AI unified in one single platform. So what are the actual components of that? Because that sounds a little bit too good to be true. So one, we're going to start with this nice confetti-looking slide over here that Phil will kill me for. But it's saying all of the clouds, all of your data. Right? You want to look at the entirety of your data that's sitting across any of the different clouds. Now, how do you make it meaningful? Right? Because many of us who've been in the industry for a while have been burned by the fact that we said, dump all of your data in there. We picked any water analogy, data lake, data stream, data reservoir, and then magic will come out of it. Well, that doesn't work. We actually need some intelligence on top of it. So it's like, okay, first, I need some concept of unified data management. When you have data, the one fundamental principle of data management is garbage in, garbage out. So now how do I think about, as the data is coming in, I want it to be high quality and reliable, right? I don't want partial things. I don't want bad data. And then I want to make sure that it's performant. If you get it in there, but it's incredibly hard for me to use, it's difficult. So one, now you've got the layout of this data that's great. It's high quality. I can get to it fast. What's the second thing that you need? You need this concept about governance. So how do I think about security? Not everybody can access the data. Who can access the data? What did they do with it? But then how do I also make it consumable? You can have really high quality data, but if I can't find it, I don't know what it is I'm looking for, it's kind of useless to me. So this whole notion of governance around both security and cataloging and tagging so people can get meaning out of it. Now, when you've finally done this, you've kind of taken this governance model. I've got high quality data, I know how to find it, and it's consumable and secure. I can start looking at what are the different workloads that I want to operate on top of it. Whether that is the BI and data warehousing, we talked about data engineering and orchestration, we talked about real-time applications, and then we talked about exploratory data science and machine learning, be able to put things in production. And so when you look at this concept of a lakehouse, it's not a big surprise. That's what Databricks has driven towards. So the Databricks Lakehouse platform that you'll be hearing a lot more today, you can see that those core pieces, Delta Lake is delivering, reliable and performant data management layout. Unity Catalog is this notion of how do I get security and consumability. And then there's core parts of it that drive all those different types of workloads that we talked about. Now, again, as I said, if anybody walks into your room and says, look, great, I have this great platform, and it solves all of your needs, you don't need anything else, you should throw them out of the room. The reality is it's a rapidly evolving ecosystem, and if it's a true platform, it's only going to be successful if it works with other pieces. So that's one of the core parts of the Lakehouse platform. As you look at all these areas, whether it's ingestion, pipelines, and governance, that there's this huge wide ecosystem of partners that have deeply integrated with it that allow you to be successful. And again, that is one of the big tenets of being open, because it creates clear standards that people know how to integrate with, and they're eager to do it because they can see the adoption that it drives. Okay? And now this platform being successful, as you might imagine, you go back, you have this, we could see organizations are successfully driving those different use cases we talked about: customer engagement, product development, workforce experience, and business operations as well. Okay, so it's Lakehouse. Great. We came up with a catchy name for it. Databricks has been pushing it. How do you know that we're on the right side of history? Is anybody else, taking note of this? And the reality is that over the last couple of years, you've seen the evolution that everybody said, you know what? This is absolutely the right place to go. And the reality is, you think about Lakehouse. Lakehouse has walked in and said, hey, can I take the benefits of what you've done with data lakes and with data warehouse, bringing all together into one system? I've never walked into a room and somebody's like, you know what? I actually don't like that. I preferred my picture over there with 5 of everything. That was more fun. The reality is, most people's question is, yeah, that sounds great, but people have been telling us that for years. Can you actually pull it off? Can you actually do it? And I think with some of these components that we showed around basically Delta Lake and Unity Catalog in that trend, it proved to the industry and organizations that this is real. And you can see that when you look at some of the organizations, right? So, for example, I'll look at the hyperscalers on Azure and Microsoft, right? Clearly the domain of SQL DW, data warehousing organization, and data warehouses are typically proprietary data tightly intercoupled with compute. You could see that they fully shifted into the other direction. Now, if you looked at Ignite from a couple weeks ago, it's all about, Delta as the core layer, everything being these serverless queues that hit it as well. Obviously, Azure Databricks is a big service on there, but Microsoft talks about Lakehouse is absolutely the future. Then you'll look at, BigQuery. Marketing is kind of questionable, but BigQuery magically now became Big Lake, where they're realizing, look, most people are dropping their data in GCS, and how do they run all the different engines around it? Think about, governance. It's all about this concept of an open data lakehouse. And then if we go to AWS was historically the domain of Redshift. That's your core data warehouse. Now you look at everything that they're talking about: data in S3, lakehouse architecture, open formats, governance, and having all those different compute engines. And then even you look at kind of, a data warehouse in the form of Snowflake, looking at it, which is like, look, I get it. We much prefer people to put data in our proprietary data format. That's kind of what we've optimized for. But the reality is data is going to sit in an open format. So how do we make sure that we support that of, data sitting in Delta and being able to emulate a lakehouse architecture, or try to, at least. Okay? So great. Now you have a problem. So Lakehouse is on the right side of history. Everybody's excited. But it's the same thing that happened when big data came out. Everybody's going to tell you, Lakehouse is the future. I have a Lakehouse, and my Lakehouse does everything. It solves all your needs. It'll solve COVID, world hunger, cancer, you name it, we'll do it. Every marketing website, and we get asked by enterprises like, how do I understand what's the difference between them? How should I stack them up? Well, so let's look at that, right? How would we compare them? Let's just start with performance. Performance is a decent place to start. And so what we did was say, okay, what is a Lakehouse defined as? A Lakehouse has your data in an open format, and oftentimes when people think about performance in these days, they say, well, we come from the data warehouse world, so let's look at the analytics workloads and how it performs. So we said, okay, let's have a third party run a benchmark and say, let's put all of the data in an open format, in just a normal open format, Parquet, and then say, can we look at Databricks touching it, as well as all of the different data warehouses touching it. And this is just TPCDS, which is considered the industry standard for synthetic workloads of benchmarks of looking at it. And what this shows you is the total cost for doing it. And you can clearly see that tiny little box all the way on the left is Databricks. And then you could see all of the basically cloud data warehouses, what they cost. It's a lot. All the major ones are up there. Happy to kind of share which are the different ones that we tested. But you can see it's a lot cheaper to do it in Databricks. So this is price performance and on performance as well. Now, the data warehouse will be like, wait a second. You are comparing this. This is not fair. Our entire business is, predicated on this fact that you need to do all of this work to put it in our nice, neat, proprietary format, and then we'll be super optimal. If you do that, we'll blow like Lakehouse out of the water. There's no way that they could actually compare to it. We said, okay, let's test it out. So then we said, you know what? Let's actually look at the cost. We'll let you put it in your proprietary format and run the same queries against it, again on TPCDS. And basically on Databricks, we'll do the same. And one of the funny parts is these data warehouses, not only do you have that work of getting the data in and then the query, but there's a ton of charges you get on the back end for what they call auto clustering or optimization to kind of perfect the layout. So let's look at what this looks like to load the data and run it. And you can see from a Databricks side, the cost is $76. And this is, basically the leading cloud data warehouse, or one of them. You can see the cost is significantly more. Even if you take it out and say, I'm going to take out the cost to load the data and to cluster it, and I'm only going to look at the query cost, Databricks is still cheaper on a query basis. So the reality is, and look, benchmarks are benchmarks, but this has kind of finally moved that across where people said, yeah, it's great, but using an open format, separating compute and storage, that sounds great in theory, but for these core performance workloads, you can never match performance or cost. And this, frankly, says it's not true. And it's innovating faster on this side as well. Now, benchmarks are great. Benchmarks are good. But what we really care about is what about organizations? Like, are they getting benefits? And so on Databricks, we have tons of people migrating, Teradata, Exadata, Netezza, as well as, their, Synapse, Snowflake, and Redshift workloads onto it. So let's look at some of the benefits that they're getting from it. So 3 examples here. So Johnson & Johnson, a global pharmaceutical company, shows that they had a bunch of data sources, both data lakes and significant data warehouses as well. And they wanted to look at their supply chain management process. And put it together and say, hey, can we have more predictable inventory? And you can just see some of the statistics here that they're talking about. Huge improvement in the speed that they're getting data, right? Because they bypassed all that. How do I get the data? How do I make it consistent? It's stale. And those actual data engineering workloads of bringing all that together reduce costs by nearly 50%. Then let's look at Sam's Club, right? This was in the early days where, one of the use cases there, COVID had just come out where everybody was looking for apparently disinfecting wipes and flour because everybody was baking. And they were like, where is COVID hitting? How do I figure what to send where? And so they said, I have all of this data. I need supply chain data. I need IoT sensors. I need store data. Can I pull it all together to figure out where to spend the fresh supply of food? Where do I put everything? And able to take all of this data, again, was spread out across a bunch of data warehouses, separate and then AI engines as well. They said the speed that they were able to get to insights was far faster, and their belief was over $100 million of savings from reduced food waste that they were going to have. Okay? And then lastly, Atlassian, almost any engineer in the room has used Jira, so is well familiar with Atlassian. They have all this data, and they've historically been saying, okay, great, we help with your Scrum management, but how do we actually help give insights to it as well? How do we serve this up to customers? This data is bifurcated a bunch of different things. Each customer has their own data, want to join it with other pieces, deliver a real-time service as well in production. And they showed by putting everything going all in on Lakehouse, this 60% reduction in analytics infrastructure costs, and the speed that they were able to deliver new insights was dramatically greater. Okay? So now we've seen what a lakehouse is. We've also talked about, what are some of the benchmarks and why Lakehouse is the real deal, especially in Databricks, and some customers who are getting benefit out of it. We'll be going into more detail later, but let me basically dive a little bit deeper into actually building the Lakehouse and what are some of the major components of it. Okay? So the first piece that we talked about as a foundation of this was Delta Lake. Remember, we talked about how do you get data management, how do you get reliable and performant data. So what is Delta Lake? So one, as is kind of natural from a Databricks perspective, some people say it's because we're Berkeley hippies, but we clearly believe in that concept, it is entirely open source, right? In the Linux Foundation. And so the easiest way that I would say think about it is take things that data warehouses have been doing for decades and just re-engineer them to work on an open format on your data lake. And so it supports all of the different engines as a layout and completely open. So over 8 million monthly downloads, and that speed is going up dramatically as well. Now why, right? Great, I say like a lot of people are downloading it, but why do they care? If we go one layer deeper and ask, what do you care about from your data management solution? What is the user? Instead of getting into the tech details, there's a couple of things that are important to you. One, do I have strong data reliability? Right? So I want to know that as the data comes in, I'm getting the right data and the complete data. Some of these jobs from basically prepping and transforming your work could take hours or days. I don't want partial results. That's one. Second, when I hit it, it needs to be performant. I could tell you have the most pristine data, but if it takes you forever to get to it, users don't care. They're not going to spend the time. Next is I've got to be able to support all the broad use cases. I can't say, well, this is optimized for this type of query, or optimized for ETL, or optimized for ML. It's whatever you want to do with the data, it has to support it. And languages, right? Well, at Databricks, we thought Scala was going to take over the world when we started. We clearly lost that bet. But the reality is that users want to use languages that they're comfortable with. You have to meet them there. So how does Delta Lake deliver on some of these things? If you look at the mapping, one, again, none of these are earth-shattering, right? It's just about how do you get them to engineer to work. It's the whole notion of you actually have transactions. A data transformation completes or it doesn't. There's no intermediate step. And you have versioning of everything. So you can go back and say, how do I look at the data from a day ago, a week ago, a month ago? That's one of the big challenges. Let's say that you're running machine learning on your data and you identify a case of insider trading or fraud. They can't say, hey, can you reproduce that model? And you're like, actually, sorry, the data changed. You have to be able to reproduce it, whether that data, that version was a day ago, a year ago, 5 years ago. Second, from a query performance, it's saying, hey, look, how do we use a lot of better query techniques, lots around statistics, data layouts, and indices as well. Third is how do you support all of the different use cases? It's one of the benefits of taking what Spark as an engine was and continually saying, historically, people have had all names of fun architectures, Lambda architecture, Kappa architecture to separate. I have my real-time data and I have my batch data. The answer is why put that cognitive overload on folks? Regardless of how you think about it, it should support those workloads. And then lastly, it's full-blown Python and SQL support. And I don't mean some like weird dialect of Python or some random thing of SQL, but ANSI SQL and normal Python and pandas that people are used to. Okay? So now, one of the great parts about it is that as people realize Lakehouse is the right thing to go, these open data formats, there's multiple of them out there, right? Clearly Delta is out there. Then there's other ones like Iceberg and Hoodie. So again, people ask me, how should I think about them? One of the main tenets that people look at it is performance. So again, we had external vendors look at it from just TPC-DS, looking at a benchmark comparison. Higher is better, normalizing it. And you can just see it's far faster than number one and number two, right? And one of the nice things is that this gap is actually widening. because two things are happening. One, with Delta, you have an organization like Databricks who is passionate and driving it. You have a huge community as well, and just the number of customers who've deployed it are constantly identifying how do we make it faster, how do we make it better, so we can invest in it and in the open source community make it far more performant. Okay? So that's Delta as an example. Now let's move one layer up the stack, and as we talked about data governance, how do I make my data secure and consumable? And that's the concept of Unity Catalog. Why is this a big deal? So today, remember I talked about you have different governance and security models and it bifurcates it. Why does this become a challenge? One, you have to think about all the different users you have. You have analysts in there, you have basically engineers, you have data science, you have business users as well. And then you have these different assets. You're like, I have data lakes, I have metadata in a Hive Metastore, I have a data warehouse, and then it's not just data, I have ML models as well. Well, just look at what this looks like. I've got one set of permissions on files, but it has no concept of row and column, which is generally what you want to expose. Then I've got another one on tables and views, but because metadata, it could be out of sync with the actual data underneath, so it might not make sense. Data Warehouse has its own thing of those capabilities, but now this is a completely different model. How do I tie it to the other governance ones? And then now we start talking about machine learning models and the like. Well, that's completely separate. You have a whole different systems, and we use fun terms like I have feature stores and a separate security model on it. So you have this huge complexity that you put together. Now, in the face of this, by the way, again, this is on one cloud. Imagine spreading around all multiple clouds and trying to basically reason through it. It's pretty difficult and daunting, right? And then also when you take this and saying, how do I actually find data? How do I discover it? How do I know where to go? How do I, across an organization, actually share insights to make data consumable? As you can see, this problem compounds, and it's no wonder that many organizations talk to us and say, governance is one of the hardest things that I have to tackle. I can't even get to the other pieces. So now how do you solve it? So what does Unity say, right? So Unity says, okay, look, why don't I take the right, why don't I take the left of the users, and why don't I give you just one model, right? So all of your data, regardless of the cloud, regardless of the format that it is, regardless of whether you want to do data, analytics, and AI, and not just your data, but those models and dashboards and features all in one place, right? Second, I'm going to give you a couple of other things. One, remember I said meet users where they are, not some complex esoteric language, but an easy-to-use UI, or just ANSI SQL grants, which is what most people are going to be used to coming from the database world and securing assets. Second thing is it tracks lineage. Why do you care about lineage? Is it tells you, okay, the data that you have, where did it come from? How do you derive it? Two reasons that's really important. One, it's that I now know if something changes upstream, I want fresh data. How do I make sure I filter everything out so all of my tables are fresh? And the second thing is, remember that you're trying to collaborate as an organization. If you have one person describe something as country and another person describe it as locale, understanding that they're derived from the same table, so they are the same thing. So how do we help them understand the semantics of that are two big problems that it delivers to you outside the box as well. Okay? So when you look at the benefits and trends of this, it's this notion of having one unified system for both accessing and auditing across all the clouds, far faster as people can find what they're looking for, both insights and discovery. That's a second benefit. And this last one is that it's completely open, right? Especially talking about data sharing and collaboration. So one of the big things about that, let's talk about data sharing for a second. Great, you have a catalog, but increasingly organizations are trying to figure out, how do I share both within my organization, but with other folks as well, with other organizations? And we're seeing the use cases for that are exploding that I want to share with them, but I want to make sure I can share all of the data. Couple of issues if you want to do that today. One, you have two options. A, do something really kludgy of saying, take your data, stick it on FTP or make multiple copies of the data, share it with people. It's error prone, it's costly. And then also, how do you keep it in sync? How do you give them fresh data? The other one is somebody will say, hey, we have a great data sharing product, but everybody has to use our product. It's this nice proprietary product. All the players have to use that one exactly. Well, I don't know if you've ever tried sharing with people. It's really hard to tell them, you can do this, but you have to use this system. And oh, by the way, now you're limited to the capabilities of that system. If it's a data warehouse, you can only use SQL, not any of the rest. And don't ask me about things like ML models or the like, because that's not going to work. So instead, when we look at it from a Databricks perspective, we said there's got to be a better way. And so built around this concept of open data sharing and collaboration. So one, again, completely open source that you could say, all right, I'm going to take Delta, which is my data, it's in an open format, and you have something known as a Delta sharing server. 100% open source. You can run it without ever touching Databricks or anything of the like. And the nice thing about this is it says that this protocol allows you to share all of these things with any consumer. And the list of clients that they support is massive. You could just see some of them here, like you're used to normal pandas or different BI tools or kind of your favorite engine. So the nice part about this is you can get all the benefits that you want of all of this data, having actually access control around it, having auditing and lineage, and you don't have to dictate to the other user what they have to use. And so this becomes a huge deal that people say, look, I can get all those benefits without having to dictate on the other side. It unblocks a lot of the challenges that folks have been having. No worrying about replicating data, being able to do it across clouds as well. Okay, so that just gives you a little bit of a flavor. We'll obviously be going into more detail around that later. So if we step back again, from a Databricks perspective, I've talked about it. Our mission is, we talk about, it's an overloaded word, but we want to democratize this notion of data, analytics and AI. Those things that we saw the large, digital native businesses do, we want to allow everybody to go about and do it. And obviously, we think that the answer to this is the Lakehouse and the Databricks Lakehouse platform. So in terms of reaching that destination, what are a couple of the big things, that I see organizations, going through and asking us about in order to be successful? So one is how do they simplify that existing architecture? So what happened was many people were, in an on-prem world, and they had been locked into these various walled gardens. And when they said, look, I'm going to go to the cloud, it's great, it's going to be best of breed, I'm going to have one of everything. And they're realizing, well, look, the technical depth of that is, hard. It's extremely costly. So how do I go back to think about simplifying the world? How do I think about basic blocks, and what do I need to do to architect that? That's one where we spend a lot of folks with. That's why the concept of a lakehouse is appealing to them. Two is embracing that they have to get data governance right. Right, if you basically rewind about 3, 4, 5 years ago, everybody was like, here's my use case. I'm going to figure out my use case. And what do I need from compute? What is the data? I'm going to solve it in the silo. Now, as they're thinking about this culture of saying, I want to drive all of this data-driven transformation, that foundation has to be governance. How do I make sure that I have reliable, high-quality data in there, and I can make sure that people can find it and it's secure? And then the last one is, how do they have a solid plan, to migrate? There was a lot of folks that we saw, especially in the early days, that are now regretting it and try to unwind it to say, look, I was on-prem. It's expensive. The business is not happy. I know I need to modernize. But why don't I de-risk the process? I'm just going to lift and shift, get it into the cloud. That's going to be easy and inexpensive. And then I'm going to modernize. And that ends up being a disaster. The reality is that when you want to move it to the cloud, it's like, it's the same. No, it's not. It's not like it's one computer moving it to the other one. I have a hard enough time upgrading my iPhone from one version to the next. The reality is when you do that, it's going to be basically harder than you thought, it's going to take longer than you thought, and it's going to be more expensive. So after the end of that, you haven't actually improved anything in terms of delivering new capabilities to the business, but nobody has an appetite to modernize. So people are looking at, how do I do that lift, modernize, and shift when I go to the cloud to set me up in the right way for the future? And so from a Databricks perspective, how do we help you with that? There's this notion, we've talked a lot about technology, but remember I said a key part about it is that people and processes. So you have this core technology, and our goal is, how do we make people successful? We wrap it with a bunch of other capabilities. So one, we have a large bench of technical resources that kind of work with you alongside, our consulting and SI partners to make sure that you do things the right way. I'll give you an example. A lot of folks say, let me get started, let me show success, I'll figure out how to optimize it later. And all of a sudden you scale, and then you're like, how do I now figure out the right way? It's about making sure you can get there faster and do it the right way using best practices. Second, it's this notion of basically talent transformation, both through in-person and virtual training, because I think organizations are looking to develop a culture of being data-driven. And when you look at that culture of I actually want to be data-driven, I want to transform, you don't want to say I want to farm out all of those capabilities. You want to build that capability internally. So how do you think about a center of excellence? How do you bring your organization along so that they basically understand how to use this, how to get the best benefits? It both helps an organization be more agile and more cost-effective in going and doing that. And we invest heavily in doing that. And then the last one is we talk about those use cases. You have to set up a core data platform, but then you want to build those use cases on top. And so we have this notion of solution accelerators, which we've kind of built alongside of many of our consulting partners that say, how do we show you the recipes to get going far faster, both to understand the art of the possible and at the same time be able to get there far faster as well. Okay? So with that, hopefully you got a quick overview of Destination Lakehouse, both what folks are doing with it, why it's the right side of history, how to think about evaluating the different offerings, and how Databricks can help you get there. Now, that's enough for me, but I'm really, really excited to welcome one of our good friends, George Webster from HSBC. He's the Chief Security Officer there to talk about a really interesting use case of how do you basically modernize cybersecurity using the Lakehouse architecture. George, welcome.
Hello. So I'm George Webster. I'm the Chief Security Architect at HSBC. Prior, I was the Global Head of Cybersecurity Science and Analytics, which is the office that really was set up initially to start tackling some of the problems we're going to talk about. So we talked about all these use cases in the previous talks and everything. That's great. I'm going to give you a little bit of an example of just cybersecurity. And initially, I'm a data guy. I went into cybersecurity because it's hard. We talk about governance, we talk about everything else. It takes it pretty much to a whole new level. But if you just look at the stats, you can see how big a problem this really is. So an average company, someone just random on the street, you're looking at like $4.24 million per one incident. And if you have one incident, you're going to have others. But if you look at a mega corporation or a very large breach, you're talking about the 400s of millions. That doesn't include all the regulatory fines and everything else there. So it's a really big deal. We spend absolutely tons of money at HSBC guarding the security of our customers, going after fraud, all of that. We do it because it's incredibly expensive when we get it wrong. But you can also see the effects in the IT budget. So right now, it's approximately about 10% of the entire budget for IT is actually going to cybersecurity. That's grown about 2x from 2016. If you start looking at the total revenue, you can also start seeing that's, again, a huge part of the company itself. That might look like a small number, but when you look at these mega corps, that's in the billions. But the problems aren't really getting better. If you look at the projected increase by 2025, you're looking at about 10x increase. And that's the forecast from the government of how big cybersecurity and all the threats coming our way are actually impacting these companies. So this is fantastic. Cybersecurity has totally crushed it, right? Like everyone's super safe. We're better off than we were like 10, 20, 30, 40, 50 years ago. And if you look at the problem, we're incredibly tool drunk. Every single new product out there, it's totally great. It's totally going to solve the world, and we're going to totally buy it. It doesn't really make much of a difference. We're absolutely sinking the budgets, right? That budget just can't keep growing and growing by 10x, and all of a sudden all the money for the company goes to cybersecurity. It doesn't really make sense. What is the company doing? We go into these boardrooms, and we talk to all these people about all these greatest things that we're going to do, how we're protecting it, what is our risk posture, how is our controls. We have no idea. We can't tell you what the risk to the company is. We can't explain to you what we're doing, why we're doing it. We're going to do product A, product B, we're going to do use case A, use case B. We have no idea. So that's not really a great solution. Not a great solution at all. We're not doing that great of a job. But if we look at the problem and just see, what is this ecosystem? When I said cybersecurity is really difficult, it's really challenging, let's dig in a little bit. So at HSBC, we have about hundreds of different security tools. I think it's around 200 that we run all throughout the estate, all over the world in 64 plus different countries. We're looking at about, I think, 1.2 million assets all over the place. So that's a problem. How do you start to integrate all of that? How do you start to put that all in your SIEM, in your learning tools, and everything else you have? All this data is also locked into individual vendor tools or even vendor ecosystems. You got your vulnerability management thing over here. You got your identity and access management thing over there. All those tools may or may not be integrated, but they're still not integrated, which is actually going to the tip of the spear, which is the operations center. They have marginal interactions. So when I say all this data is going, it might just be a little bit of an alert. It's something someone previously decided down the road. But what happens if something's new? Cybersecurity is asymmetric. You have no idea what's going to occur tomorrow. And so what happens here is you have this little SOC analyst, and he's sitting there, and he might be doing a spear phishing ticket, and he might be having to look through 40 different tools to do it. How do you scale that? You really don't. So cybersecurity needs to evolve, right? It was pretty clear. We've been saying this for decades. You can go back to even 1983, and you can see executive orders trying to go after it. But we got to do something. We got to be faster. We got to be flexible. We got to be scalable. And one of the ways you do that is, frankly, through data. So if we look at the required state, we can't actually just put all this sort of data into it because it's very, very expensive. So how do we do it in a way that's cost effective? How do we actually start to get after this so we can start doing the interactions and integrations? We got to unlock it. We then have to be able to run and do something on top of it. How do you get a platform that enables you to do it? And really, it comes down to how do you actually empower that people? Because these tools don't work, right? It's all about that human at the end of the day. The greatest analytic in the world doesn't do anything. It's that human. So how do we enable that person? So we went actually on a vision, and we said, cool, we're going to hire a bunch of really smart people. I live in London. I was hired to come over here. We went in and said, we're going to build it. Everything is going to be great. And we said we're going to build it, though, on this stack. When we talk about the data, we decided we're going to make every single thing a sensor. We're going to pull all this data from everywhere we can. When we talk about big data, we're about 10 times all the information in the Library of Congress per day. That's somewhere between 100 to 200 terabytes, but it's cybersecurity. It's not just processing that piece of information at that time. We have to go backwards in time up to 13 months to perform an investigation. So you can do the math. It's huge. That's quite substantial. But it's also cybersecurity. We have to do it in near real time. We have to be able to pull this information. We have to process those results in seconds or minutes. So when we built this platform, we decided to take a bet. This was about 2 years ago, maybe 3 years ago. We started looking at the Lakehouse. It wasn't called Lakehouse then. It was called Delta. It wasn't even released really publicly yet. We started to play. We created this huge ecosystem where we pulled in all this data. We have it kind of in an environment where we're starting to layer on top of it with kind of Delta in various ways. We started to model it. And we started to then go to mission-driven apps. We said, we have no idea of all the different things that people want, but that analyst on the floor does. So how do we actually unlock that person? If you want to do metrics, go do metrics. If you want to do compliance, go do compliance. If you want to do real-time asset identification, go do that. If you want to go trace criminals, go do that. So at the end of the day, and the real metrics I can really show you, but there's tons of other stuff too I'll probably mention in a second. We needed to figure out how to get this data and start going at it. This is an old stat. It's from about a year ago. I think we have about 3,000 users approximately a day all throughout the company that log in and look at a dashboard. And they want to get the metrics. They want to start to understand that estate. And the metrics are fairly accurate. They're data-driven. We can actually say, this is where it came from. This is how it is. And that's actually a surprising thing, because typically we had armies of BAs running around to do this, and we were months behind. Now we have it pretty much at our fingertips. It's all automated. When we look at the security side and going after how do you secure it, we're processing billions of events per second. And we're going after and we're improving our risk. We're improving our risk posture. We're going after and starting to solve those problems. Now, when we went to Databricks, we went to the Lakehouse, and we went to Delta, one of the things and why we went after it was because it's the open protocols. We had to break the vendor silos. We had to have all these tools interact and interchange. So that open protocol, working with that open source software, was really a key item for us. It allowed us to break these vendor locks because we can start to store and process this data at a reasonable time. We didn't have to pay hundreds upon hundreds upon hundreds of millions of dollars to be able to get that data in and also run the analytics. We had a huge issue. We had to break the technical limitations, and we've definitely hurt the systems. We had to keep working through it, and we had a partner that could actually say, hey, you hit the IO threshold here. This is what you need to do. Oh, this thing for regulation, we need to go implement it. We had a partner that supported us in that process. And that's pretty much the journey. So I thank you for your time. I hope this kind of enlightens you a little bit about how a company can actually do it at such a large scale. If you do have any questions on how we did it, if you see me around, please do talk to me or please do reach out. I'd love to chat with you about the journey. Thank you.
All right, so I semi-lied. You're almost done with me. I just have one more announcement here. So one, thanks to George, it's a super cool use case to hear about. So we've done a bunch of slides so far, but one of the great parts about having a platform is actually seeing how it operates, what it does as well. So I'm excited now to be able to go through some demos on core parts of the product, where Robin will be talking about data engineering on the Lakehouse, Paul will be talking about data warehousing on the Lakehouse, and Sarah will be talking about machine learning basically on the platform as well. So I'd like with that to welcome back Robin up here to talk about data engineering on the Lakehouse. You need the clicker?
Thank you very much. So as Arsalan mentioned, I'm just going to cover a little bit of a high level of data engineering on the Lakehouse and then let you guys see a demo, because that's the best part, right, about seeing it. So I talk to lots of customers every day, and I think we've heard this across the entire ecosystem. You hear people talk about data as an asset. Data is the new oil. Data is going to unlock the future. We're going to solve everything with data, which is why we're all in the room, right? The interesting part is the future of data really is here. Every organization that I talk to is talking about how do we analyze the data that we have today? How do we think about all of the new data assets being created? And how do we think about tying that together to report on what we've done, but also more about prediction of the future, right? Every organization wants to figure out how to become more efficient, more effective, deliver better services. And I think what we saw during the pandemic, what we saw during Brexit here in the UK, what we saw with the war and conflict in the Ukraine, is that those organizations that really have a good handle on their data actually figure out how not just to survive those types of transformations and changes, but really how to thrive, how to continue to grow their businesses, how to deliver those better services for their customers. And so when we think about the engineering, it's really interesting. IDC has a statistic where they say that by 2025, there'll be 175 zettabytes of data, right, which is just a phenomenal amount of growth. The complexity becomes when your data engineering teams have to figure out how do you actually ingest and transform and orchestrate and monitor all of your historic data sets, plus these real new data sets that are being created, and how do you put that into a platform that allows you to be able to start to predict the future. And that really is what becomes complex. And so why is that complex? Or why is it complicated for your data engineering teams? First, a lot of it requires that hand coding. Arsalan referred to it earlier. All of the work that goes into stitching it together and creating your own internal code to bring all of those ingestions and transformations together. And then how do you make sure that your data engineers have the capability then to manage the infrastructure that's required to do that? How do you build and scale that and leverage your infrastructure teams to be able to deliver against that? There's the tuning of your tables for performance and scalability. Can you meet the business SLAs that you need to with the data sets? And can the data engineering team support the volumes of data coming into the ecosystem to be able to meet the needs of the business in that way? And at the same time, they're trying to orchestrate in production, manage all of the existing production workloads, create the new ingestion models for all the new data sets coming in, and manage all of the disparate incompatible systems that exist that Arsalan also referred to, where you have multiple clouds, multiple tools, multiple assets, all across different governance models and security models. And so that's why we really think about data engineering as a primary function in the Lakehouse platform that allows us to have an end-to-end single data engineering solution that lets you think about how do you ingest and transform both batch and streaming data. How do you orchestrate those workflows at scale? And how do you really increase the productivity of your data teams to be able to deliver quality data with support across the ecosystem? More than 7,000 customers are already leveraging Databricks, and a lot of that has to do with the fact that we've tried to make data engineering simpler and reliable for the data engineering teams. And so how do we do that? How do we think about that? And so there's a couple of ways. First is leveraging Delta Live tables. Organizations can start to really think about simplification of the data ingestion process, as well as automating ETL across both batch and streaming. Through workflows, you're able to actually create reliable orchestration across your analytics, data, and AI, as well as a single platform that allows for governance, reliability, and performance, as well as end-to-end monitoring and observability. And so let's take a look at how it really works. If you think about it, building the pipelines and creating the ETL process in an organization is the very first step. You have to get the data into the system for the business to be able to use it. And so what Databricks data engineering enables your data teams to do is actually unify your batch and streaming into a single architecture. So you're not having to run disparate systems for your streaming and then for your data warehousing sort of systems. It allows you to leverage sort of modern software engineering best practices. So when you think of testing, deployment, those types of capabilities, and how do you build reliable workflows across all of those sort of work streams? And so what the Lakehouse provides is sort of that single end-to-end data engineering process that automates a lot of that complexity that organizations are trying to deal with. And we do that through a few innovations. The first is Delta Live tables. So with Delta Live tables, it's the first ETL framework that actually uses a declarative approach that allows you to treat your data like code and apply modern software best practices. And so using SQL or Python, you can actually create those orchestrations, and that has the built-in capability to deliver against those ETLs. The other thing is simplifying the management of the infrastructure. So instead of your data engineering teams having to reach out to the infrastructure team every time they need a new cluster spun up or they need more capacity or storage, leveraging Delta Live tables, it automates a lot of that capability. And so they're able to do that and size up and size down as they're sort of needed to ingest that data. And then maintaining quality. So every organization I talk to talks about that garbage in, garbage out. How do we drive quality data into the ecosystem? The business is pushing back that the quality of the data in the system isn't great. And organizations really struggle on how do you create the people and process frameworks that encourage quality data to go into the system. But technology can help support that as well. And so through expectations, which is a feature of Delta Live tables, you can actually set the expectations of what you would expect the data to look like, and it can help you manage and mitigate through automation on making sure that you have quality data going into the system, as well as then report out, monitor sort of against your quality metrics that you're trying to drive your organization to. And again, really simplifying and unifying with a single API, the capability to do both batch and streaming. As organizations start to think about more real-time data insights, the capability to manage your streaming data sets is becoming more and more critical. The other thing is once you have the data ingested into the system, you have to think about the orchestration to actually make it usable. And so this is where Databricks Workflows comes in. So being able to run sort of diverse workflows, whether it's from SQL or Python notebooks or Delta Live tables or even DBT projects, you need to be able to sort of create and orchestrate that from anything and anywhere. And so really thinking about workflows to be able to enable and empower that. The other thing is lots of organizations are talking about low code or no code. And so what we've done with workflows is create a GUI interface that you can actually start to democratize some of these workflow creations and being able to draw that out. But you still have the capability to leverage the APIs against your existing tool sets or for the heavier or more intensive engineering sort of motions that you need to do. There's deep integration across the Lakehouse platform, so you're not having to move across between multiple tools or multiple systems, and so being able to do that in all one interface. And then again, it's fully managed, and you have the capability to do that. The interesting part about workflows is it's been used across all the clouds, so Azure, AWS, and GCP, and so there's hundreds and hundreds and hundreds of organizations that have been able to create and drive these. So it's really sort of battle tested across those 7,000 customers we talked about earlier. And so with that, I'd love to hand it over to Bilal, who we recorded, who's going to show us a little bit of a demo.
Hi everyone, welcome to this demo about modern data engineering with Databricks. Imagine you're asked to build a system that uses machine learning to monitor if users on Twitter talk about your company and your products in a good or bad way. Of course, before we even think about the ML model, we need to make sure we have good data for it. And that data comes from quality data engineering with pipelines and workflows. Let's look at how we might construct that. To connect to a live Twitter feed, I use a Databricks Python notebook backed up by a Git repo. With the Tweepy API, I define a search expression for my stream. That data will be streamed into an S3 bucket. Delta Live Tables, DLT, is the modern way to do ETL on the Lakehouse. I'm using DLT to ingest, cleanse, and transform those tweets. You can do that entirely in SQL, but we also support Python for DLT in case you prefer that. DLT data pipelines are declarative. The Lakehouse platform provisions the underlying autoscaling infrastructure, creates the tables, and figures out which tables have to be updated in which order. Following the medallion pattern, where data quality is improved going from bronze to silver to gold tables, I describe my first live table in SQL, the bronze table. It's a table that uses autoloader for ingestion. Note the keyword live here. With autoloader, data ingestion becomes as easy as dropping files into a folder. Autoloader is using this directory. It can infer the schema, which is a convenient and time-saving feature since every tweet consists of more than 40 different attributes. Now, thanks to autoloader, I don't have to manually map all those column names and types to table schema. From now on, I can rely on the bronze table with a proper schema. Autoloader itself is a streaming data source, so a single tweet will be ingested exactly once, and I can create a streaming live table. Streaming live tables are stateful. They work incrementally and remember what state was processed already. My second live table, the silver table, depends on the bronze table. This silver table drops the rows with unsuitable data. It also removes unnecessary columns from the data coming from the bronze table. The goal is to create data fit for the ML model. To ensure data quality with DLT, I can use a feature called expectations. An expectation is a constraint with an action to take based on a condition. For this use case, I make sure that I only use English tweets because my ML model was trained with English text only. All the other tweets will be dropped. A third table in my pipeline computes a simple histogram of all the different languages in the tweets, because that's something I'm curious about. For the running pipeline, I can see the lineage graph. Here, I trigger the pipeline manually. If I run it again, it will only read the tweets that arrived since the last run. Under pipeline settings, I could set the pipeline to continuous mode to keep it running and reduce latencies. Here, I can also enable enhanced autoscaling, which is improving the throughput and therefore reducing the cost while keeping the latency low. The target setting allows me to run the exact same pipeline in development, staging, or production environment. Finally, in my third notebook, I use a Hugging Face transformer. That's a pre-trained ML model for sentiment analysis that even understands about emojis in tweets. The cleaned Twitter stream, that is the output from the Delta Live tables, is the input for my ML model. It's a Delta table. The final output shows a pie chart assuring me that like 93% of all tweets are either positive or neutral, and a word cloud displays the most frequently used words in those positive tweets. The ML model shows that we're good. People love Databricks, DLT, and workflows. Obviously, you do not want to juggle with all these notebooks yourself, but use Databricks Workflows, the fully managed orchestration service which is built into the Lakehouse platform. For my use case, I orchestrate 3 separate tasks. The Python notebook that reads the Twitter feed, a data pipeline built with DLT to prep the data for ML, and the notebook running Hugging Face for sentiment analysis. If I try and add another task, you can see that there is a vast selection of different task types that can be orchestrated, such as jar files with a main class, Spark jobs, Python scripts and Python wheel packages, as well as data flow pipelines in DLT or DBT. Once my job is scheduled and running, I'd like to get some insight whether it executes without any failed tasks. I can look at all the runs. And speaking of observability, my favorite view is the matrix view that shows me the jobs over time. So long-running jobs and errors can be spotted easily. If an error occurs, I can use the repair and rerun feature to rerun all the downstream tasks that were impacted. This saves significant time and costs. Hopefully, now you've got a good idea of how to build a streaming data pipeline with Delta Live tables and orchestrate all data engineering tasks with Databricks Workflows. With modern data engineering on Databricks, you can easily ingest and transform batch and streaming data.
Super glad that we could show you a demo then of some of the new and upcoming functionality. Please do feel free to take a look at GitHub or leverage the QR code if you'd like to access to the notebooks that were used during the demo and check them out yourself. The other thing is, feel free to check out Databricks.com for a getting started guide around data engineering. And we'd love to see you at any of the breakout sessions that are later this morning and this afternoon, specifically on data engineering, including the Delta Live table session, the Databricks workflow session, or the data streaming session. And with that, I'd love to pass it off to Paul to come up and share a little bit about warehousing. Thank you.
Hi, everyone. So I'm Paul Leventis. I head up R&D for Databricks in Europe, and I was working on our Databricks SQL product for the past few years. So I'm going to tell you why the Lakehouse is your best data warehouse. Clickers. There we go. So the classic data warehouse really can't keep up with the world today. We have, you want to combine together these different types of data and these use cases. You have a lot of variety, a lot of types of data, a lot of use cases. And doing so unlocks the value of your data, unlocks innovation. You can apply ML, you can apply AI, you can go from retrospective to predictive work. And that requires a lot of agility. You need reliable data, you need real-time data, and if you have a lot of different complex systems interconnected, it's hard to have that real-time nature, and you don't want your data locked in, you don't want it duplicated. That turns into cost, it turns to complexity, and you just can't scale. So the best data warehouse, is a lakehouse. It lets you build on top of your data lake by putting your data, analytics, and AI in one place. It gives you world-class performance, but with the economy and cost of a data lake and the simplicity of one source of truth for all your data. And I'll give you some more insights into that. Clicking is hard. We heard about a couple of these success cases already, but we have a lot of customers who have production workloads running on a data lake, on a lakehouse architecture, and have been successful with this and seen big reductions. We heard about Johnson & Johnson already. The Atlassian case is really cool because what's happened is that they've broken down these silos of a legacy warehouse application and multiple separate applications, and they've really kind of opened up access in their organization to petabytes of data across thousands of users across HR, marketing, sales, finance, R&D. And that allows these users to discover new use cases and build new applications on that data without having to involve a central data team as much. And so, and you get these new applications out faster, 30% less time to get these applications out and with less internal support and saving costs on the deployment compared to the warehouse before. Or in the case of Shell, where they are using they're breaking down these silos within this large multinational application, and they're able to look at, for example, the learning that they have across IoT sensors in many different applications to better predict failure of machines in the field and saving themselves lots and lots of money in maintenance. So, you know, all of this is powered under hood by Databricks SQL. This is how you get your data warehousing on your Databricks Lakehouse. Databricks SQL is a serverless data warehouse offering. It lets you run all your SQL and BI applications on your data at scale, up to 12x faster price performance compared to other cloud data warehouses. And it uses that unified governance model, the Unity catalog we heard about earlier, as open formats and APIs. And you still get to bring the tools of choice to the table. You're not locked in. I'm going to focus a bit next on the price performance and the sort of data silo aspect, because we've heard already about these other two facets. So if we look at performance, you know, classically, Databricks is fantastic for your big data engineering, you know, large data set processing. And you can see this on the left, where 100 terabyte TPCDS benchmark that last year we set the world record for, where we're showing, you know, 12x better price performance compared to, depending on which cloud provider we look at. And so that's a big application. But we also, the same engine works really, really well on smaller data and the nature of, you know, smaller lots of simultaneous queries that you might see in an analytics workload, where we're driving up the number of concurrent queries that we can handle in the system. Since our early preview to today, we have 3x better throughput in terms of queries per hour. And we're not standing still. We're continuing to improve on this technology to make it faster and improve the cost for our users. We've, since setting that world record last year, we're almost 50% faster than we were at that time. And the way we do this is with a new engine that we built. We had steadily been improving the performance of the Databricks runtime for our data engineering applications over the years, and you can see those bars in the chart on the right. But what we did is we decided, hey, we need to build a new engine that was built from the ground up to be massively parallel, leverage all the modern capabilities of processors for simultaneous processing of data. And what this turns into is speed. Speed is great because speed is cost when you're talking about cloud and computers. Speed is also getting your answer faster as a user. It gives you 3 to 8x faster interactive workloads, at 1/5 of the cost on ETL, or 1/5 of the compute. And on average, it's giving 30% TCO savings to our users. It's battle tested in production, exabytes of data processed, billions of queries that have run through this engine already. Now, Databricks SQL also works great in a serverless setting. Now, serverless is awesome because serverless is elasticity. It's instant elastic compute. You fire queries at a system, and the system responds with the right amount of compute for the queries that you have at that time. Your first query runs quickly because you can provision those compute quickly, and as it needs to scale up, it does so. That's great for the user. You get your answer fast, good responsiveness. It's also great for the admin. You don't need to worry about capacities and pools and instance types and so forth. This is managed for you under the hood by Databricks. And it also gives you a more simple and predictable pricing. And obviously, that's great for your bottom line and your IT budget because you get better total cost of ownership. You don't need to over-provision your system, have compute waiting in the wings in case a burst comes through. And you don't have machines sitting around idle that you're paying for. There we are. Now, we have a couple other tricks that help improve the performance of the system under the hood. one of the challenges you face in these systems is you have mixed workloads. You've got some small queries and big queries, and you don't want to have to think about and segregate these systems into different warehouses. That adds complexity. We don't want you to have that complexity. We can handle mixed workloads quite well in the system, and we leverage our expertise in machine learning internally to have built a predictive model under the hood that looks at workloads and how they've behaved in the past to do a better job at making these difficult decisions under the hood of, do we scale up compute, do we inject a query, do we wait and execute it later? And all of that is done intelligently under the hood in the system for you. And since we deployed this sort of machine learned model, we were able to improve the average latency in mixed circumstances by a factor of 3 without increasing the cost. We also have another bit of tech that will, just a teaser for a session later today that dives more deeply into Photon. But when you're doing highly selective queries, which are very common in especially analytic and interactive cases, you have some choices to be made here. It's easy to just do a simple selective query like this, but it's not going to be fast. If you want it to be fast, you might need indexes, and then you have to think about which columns am I setting up indexes and what types, and that's very complex, and it's costly. So how do you kind of manage this? And our answer is we don't want you to have to think about that and manage that. So we have a capability to predict to do a much better job of predicting and looking at the nature of access patterns, and based on this, reduce the amount of data that needs to be read without you having to manage indices and without big auto-indexing costs in the background. So if you want to hear more about that beautiful little sweet spot there, you can hear more today in one of the breakout sessions. Now, let's talk about the data silos for a second here. You want to be able to access all your data. You can access your streaming tables. We saw the DLT example where you can connect to these, and you're not managing a detailed ETL pipeline. All of the complexity of that's handled for you by Delta Live tables. You can federate your queries. You can access data sources that are not just inside a Databricks. You can connect to external sources. They show up as tables as well in your catalog. Makes it easy to access data wherever it is without extra copies. And you can access semi-structured data or JSON and also get great performance. On top of that, we want people to be able to bring more powerful analytics. So you can connect to machine learning capabilities. You can also do geospatial processing. We have native support for H3. It's a way of processing data that has a geographic location aspect to it, and we're very performant on that type of data. And if we don't do what you need yet, you can bring your own capability with Python user-defined functions. Now, Databricks SQL warehouses sort of sit in the center, but you don't have to use just the built-in capabilities. It can be the warehouse that powers all the tools that you're used to today, whether that's on ingest, whether it's querying, whether it's transforming your data. And I'm going to show an example of this in a demo now. So what we have here is, you can see Databricks. We have the SQL view at the moment, and we're going to go into the SQL editor. So as you'd expect with a warehouse, there is a box sitting here. It's waiting for you to type some SQL. We're going to set up a query quickly here where I'm going to query a data set called the New York taxi cab data set that we have as a sample in Databricks out of the box. And we're going to just fire it up. It's executing against a serverless warehouse that was currently stopped. That warehouse is firing up and launched the query and is going to give me my table right now. And so that's the speed of having a serverless endpoint. Now, that's not a very interesting query. We're going to do something a little more interesting. We're going to go select, hey, let's find out what are the most common zip codes that people drop off with taxis. Zip codes are something like some postal region or something in the US. So we're going to go do this. I'm going to type some SQL, and you can see all the things you'd expect. There's context-sensitive name completion, tells me about what data I can access, what functions I can use, so forth. Type this in. I'm going to order by the zip code and aggregate it and get a nice result, fire it against the warehouse, and sure enough, I can see one particular zip code has the most taxi cab drop-offs. Great. Now, that's not too useful because I have no idea what that zip code means, and I mean that literally. So we're going to go look this up join it with another table that's in this catalog, which is the zip map. So some magic SQL arrives. We're going to make a few changes here, and we're going to join the data, the zip code data that we just aggregated with this table that lets me understand what those are, turn it into a set of cities so we can find out which city, and the answer is probably New York. While that's running, I've gone and I've renamed this query. I've given a useful name, New York City drop-off, so that way I can find the query later. I could share that query with other people. I could schedule it. And I've got my result. It's New York City, has the most drop-offs. OK, not too surprising, I guess, if you're from there. Now, I can see past executions as I've been editing these queries. I can see, as I've been developing these queries and the results of those queries. So I can go back and forth, see what I did. Oh, something changed. I can go back in time. That's all happening for me sort of under the hood here. And you also might have noticed on the left there was a schema browser. We could see the data that was accessible to me. I can see more details about this query, what happened when it ran, how many resources used, was it IO bound, CPU bound, go into a visual explain of the query. If you're deep into database details, you can see the join, see the graph, see the exact details, maybe where your data was bottlenecked or why did it access so much data. You might, maybe it was a lot less selective than you intended it to be, and you'll notice this in this debugging view. So we're going to, it's tedious to be constantly sort of building this other sort of zip code table on the fly. Maybe I want someone else in my team to be using this data as well. So I'm going to create that table, materialize that, and add it to my catalog so someone else can use it. I'm loading a query that was already made that does this. That will basically take that same portion of the query, materialize that as a new table in my New York taxi cab database, and we'll execute that. And what we're going to see is that if I navigate to the tables, look at my catalog, I'll be able to see this data now exists. Rating here. OK, so we go down to our data tab here, where this is our data explorer. It lets you explore the data that's in your catalog. We're going to go into this part of the catalog where we have our New York taxi database, and you can see there is now a table for the full trips, which is this aggregate that we just created. I can see the lineage of that data. I can go in and say, where did this data come from? I can see, we know that it came from these two other tables. It was produced as a function of these. So it gives you an idea of being able to see the provenance of your data, understand where it came from, and understand data that's in your system, so that way it helps you with both discoverability and understanding and tracking of what's going on. Now, if we go look at one of our warehouses here, we've been executing against this particular warehouse instance, the serverless warehouse. I might want to connect an external tool. And so I'm going to go in here. I can see the details of if I want to connect an external tool. I'm going to say, let's connect it to Tableau. It downloads a little blob of info that opens up in Tableau. I could have connected JDBC or Java, other things as well. And we're going to launch Tableau. I'm going to type my super secret password here to log in. And here on the right is Tableau. I can see the same catalog. I can see the schema. I can see the data. I can see the table. I can go and do my exploration that I would want to do, and Tableau, powered under the hood by a Databricks SQL warehouse on your Databricks Lakehouse. You're getting all the same TCO benefits and compute and simplicity, but you're using the tool set you're used to. Great. Now, so with that, I'm going to pass it off next to Sarah, who's going to tell us about machine learning on Databricks.
Perfect, thanks. So, hi guys, my name's Sarah, and welcome to the Data and I World Tour. I'm a solution architect here at Databricks. Let me check I've got my slides. Yep, all good. And I'm keen to talk to you about the vision of machine learning in the Lakehouse. Finally. So when we think of machine learning, there's multiple different concepts that can come to mind, from algorithms to hyperparameter tuning. But there's one thing that we can all agree on, and that's the potential value that machine learning can bring for our organization. Now, that journey can be complex. So there's a lot of different challenges and hurdles that we can overcome, from taking a model and putting it all the way into production, and making sure that it unlocks continuous value for our organization. Now, that can be due to a range of different aspects. So it could be your data engineering stack. It could be data silos, complexities in your infrastructure. It could be due to tooling inconsistencies. But luckily, with Databricks, we provide a data-centric machine learning platform that allows you to operate in the lakehouse. There we go. So 1 second. Perfect. So with Databricks, we provide a holistic experience, whether that be kind of doing your data preparation or your experimentation, all the way through to maybe deploying a model, all within the same environment, same platform, same set of governance, same set of tools that you would use for your standard data that you already have maybe in your lakehouse. Now, well, we've jumped ahead slightly, but it's fine. It's all a surprise. Now, the key thing with kind of data, and we'll start with data as it's the kind of heart of what we do, is that data operations, data preparation can sometimes be super complex and resource intensive for our machine learning engineers or our data scientists. I came from a data science background, and I would spend 80% of my time cleaning data, and then another 20% of my time complaining about cleaning data. So what we've tried to do is we've tried to create the feature store to simplify this process, to bring our data scientists and our data engineers much closer together, so that ingestion, preparation, and processing is much simpler. Now, this is all underpinned by Unity Catalog. So this allows you to track and monitor your data as it moves from your source to your feature store. And we'll show how the full lineage of the end-to-end picture is built as well. Now, once we've kind of got our data in our feature store, we can then start to move to experimentation. So there's kind of lots of different paths that we can go down, but we can start with initially looking at a code-centric approach. So we can start with notebooks. If we want to start to try and build like a low-code auto ML approach, we can do that. So we can take our AutoML and point it at a table or a feature store, and then automatically generate a model. From there, we can then go in, and it will show in the demo, we can go in and tweak certain aspects, and then move that into production. Now, this is all underpinned by MLflow. So this means that you get the ability to track, register, and maintain those models as they move throughout the life cycle. Now, once we've got our model and we're happy with it, which might take a fair while, given which data scientist you might have working on the model, we then can move to deploying the model. Now, with deployment, you've got the ability to use our real-time serverless inference, which is a bit of a mouthful, but it's beneficial. So you've got the ability to scale up or scale down, providing low latency and super fast auto-scaling to match your kind of business needs. And then once we've got to the point of deploying the model, we'll then need to monitor it. So we'll need to look at things like the lineage or some of the out-of-box capability. Now, because you're using Databricks on one single platform, you've got the ability to track your end-to-end life cycle from that source data to the point of serving. Now, if it's going to click, there we go. So I guess the key piece here is kind of, I guess, what makes us such a kind of data-centric platform. Well, you're directly building into the lakehouse. You're building on the foundations of Delta Lake onto MLflow. You're creating, or you have the ability to use the feature store, so bring your models and your data much closer together, creating feature-rich data sets that are discoverable and reusable across multiple different pipelines and teams and models. And then when we use Unity Catalog, you've got the ability to take a table and transfer it into a feature table. So again, breaking down the data silos. Now, another key aspect of using kind of Databricks is the fact that you're using a production-ready platform. So this is where serverless real-time inference comes in. So again, that capability of being able to serve your models, whether in batch or in real-time mode, and to be able to scale up or scale down, depending on your business requirements. And it will scale all the way down to 0. And also, we have super low latency, as you can see on the screen. Now, if I tab, there we go. We've also got Lakehouse monitoring and governance. And because your code, your models, and your data are all within the one platform, you've got the ability now to access all of that data, because it's all tables stored as such in the platform. You can access all that data and create a stitched-together end-to-end process. You've got the ability to perform some of the out-of-box analytic capabilities. So with MLflow, you can see some of the model quality, so data drift or latency on those endpoints, and you can track these. So your engineers aren't spending effort and time recreating a standard process multiple times throughout the organization. You've also got the ability, because all of your data is tabular and you can access it as such, you can build a better picture of your organization and the impact that ML will have on your business performance. So you'll be able to tie that together. Now, the other key thing with the fact that everything's stored as tables is you can start to see the full lineage. So you can start to debug certain aspects of the platform as well to make sure that you're deploying the most optimal pipelines. Now, I'm quickly going to go through a demo to show this in a bit more depth. Perfect. So the example that we've got here is that we're going to build a supply chain optimization project. We've got a store, and they've got different individual stores within a chain, and they want to see what the forecast looks like for those. They've had several kind of core challenges to start with that you can see on the screen, from being able to deploy models quickly, integrating model-related data with the rest of the business data, knowing if a model's performance was degrading over time. And what we're going to show now is the Databricks platform. We're going to zoom into the data science persona, functionality that is built specifically for that persona. So you've got a bunch of different features down the left-hand side, and we're going to start with the feature store and where our data resides initially. So as we click into the feature store, you can see all the feature tables that exist. If I click into one of them, I can see all the metadata that's captured with that feature store table. So I can see when it was last modified, when it was updated, who owns that. We can add tags to that, so you can add your business alignment or maybe a use case group. You can see where the data comes from, and you can see if you've got an online store for the online serving capability for these features. Now, what I'm going to do is I'm going to slowly go back, and I'm going to show you the description. And this is kind of the pipeline to create that feature table. So as you can see, this isn't too dissimilar from your data engineering pipelines. You can see that you've got your initial bronze tables that's going to be cleaned up into your silver tables, and then you've got your individual store tables. And we can see that completing. And we can see the health of the DAG throughout its journey. Now, what we're going to do is we're going to go back into the feature, and we're going to have a look at some of the modeling capability. There we go. So we're going to look at the data side of things. We're going to have a look at the capability that the Unity Catalog brings. So if I open Demo UC and the supply chain, I can start to see some of the tables that have been built. In that, I can see who owns the data, some of the schema around it, the permissions, that might be groups, and I can start to look at the lineage graph behind this. So this is super important for compliance and regulation. I need to see what's affecting kind of which data sources are feeding into which models, which features are being pulled through, and what the pipeline looks like. I can then go back. There we go, and we can look into creating a model via the notebook functionality that I mentioned earlier. So with this, we can connect to some pre-configured compute, and with this, we've got all of our Databricks runtimes attached. So you've got all your libraries, your common ML libraries that you might need to use. Now, this is super important to see kind of the code-first approach, and we can run the cells individually. And again, we can scroll through to see what that looks like. But what we'll show is how to create an AutoML experiment. So this could be you're creating a baseline model that you're then going to tweak later. You might just want to do some noodling and some experimentation, and you can do that here. So you select your problem type, you select your data set. So you could select your pre-configured feature tables, select your target, and your time column. There's some additional parameters that you can place in there as well. And then you can save the experiment name however you wish. Now, we can see that there's lots of experiments, and here's one that I've created earlier. So this is my Blue Peter moment. And we can see here that we've got the source for each of the notebooks, which we can go into, and this is automatically generated. So all of the code you see here has been automatically created as part of the training runs. Now you can go in and you can change different capabilities, or you can tune some of your parameters, or it might be that you want a different split, for example, and you can do that. We can also look into, let's load in, there we go. We can also look into some of the metrics behind that, or the actual model itself. So we can look at some of the artifacts. It might be that you want to take the pickle file and deploy it in a different mechanism. Again, everything that you see here, you can also follow from a command line perspective, or an API-driven perspective. You don't have to always use the UI. But if you've got a model that you're happy with and say this is the best model that you've got, you can then register that model, save the model name, and what you're doing is you're registering it here in MLflow. The model will then register. You can then open the model and start to look at the life cycle behind it. You can transfer the model from stage into production, and there's a lot of other things you can incorporate at this stage. So there's a talk later on MLOps, which will cover this in more detail. And depending on your rights, you can transition this into production. Once you've done that, you can then use your model for inference, and you'll have the choice to either go for a batch inference approach or a real-time inference approach. Now, it's as simple as just clicking Enable Serving, and then you'll have your compute behind the scenes, which again will scale up and down depending on how frequently the model is used. We can also start to see model versions, model events, and any of the cluster settings. So whilst this is kind of loading, we'll be able to see the version of the model. So this is version 40. We can look at some of the code behind it, or we can look at some of the kind of pre-built monitoring aspects. So you'll be able to see CPU usage, latency, memory usage. So these will help you to optimize your MLOps pipeline. Again, if you want to call the model, you've got the ability to do so as well. So you can build that in. And we also have DB-SQL. So we've got the ability to now view this dashboard. So again, built in the same platform, just with a different persona view. So now you can start to incorporate some of your business data with your model outputs to work out, okay, how are my individual stores performing? For example, my store inventory data throughput. I can look at individual performance, or I can split this out however I wish to. It might be that this might be too operational for my end users, but I can create custom dashboards for each of the stores for argument's sake. Now, once we've got kind of this, we can also set alerts. So for example, if your performance metric drops below a certain threshold, you can trigger so that you can either retrain, or it might be that you then want to have a look back into it. It might be that you want to fall over or productionize a new model and have kind of, I guess, built into your MLOps process. Now, what we've covered today is kind of the three core aspects, first starting with data prep and data ops. So the feature store and Unity catalog will allow you to bring your data engineers and your data scientists closer together to create reusable features for your ML pipelines or your ML models. And Unity catalog will allow you to track that. Experimentation and model ops, we've got multiple different ways of doing that, from notebooks to AutoML. And we've got deployment and DevOps. So again, you've got the ability to serve that model in a frequency that matches the business need. Now, this is all wrapped up within kind of a view of the ML lifecycle. And you don't have to just take my word for it. So we've got lots of different customers that are using kind of our ML capability today, from kind of Coca-Cola to Amgen to Rolls-Royce. So I think that's the end of my slides. It should be. But yeah, thank you so much. And I think I'm going to pass back over to Robin.
So I promise this is the last time you have to see me this morning. Can you just help me give one more round of applause for all the speakers? Thank you so much for... So just a reminder, there's 4 breakout sessions this morning that you can choose from. Please take note of the location of the one that you want to attend. Feel free to grab anybody with a Databricks lanyard, and they'll help you find your way if needed. We will start promptly at 11:15, so I know we're running a few minutes late, but you should still have time to grab a cup of coffee and get going down there. We'll have lunch down Downstairs again, the afternoon sessions, again, there's multiple options, 4 different breakouts that you can choose from. Please feel free to select any ones that sort of appeal to you. And then again, we would love to see you this evening at the networking reception. Thank you so much. Have a great Data and I/O World Tour.
I wanna go missing.